Hello, so welcome to the video. Today we're going to take a look at how to do Spearman correlation analyses on SPSS. So Spearman correlation analyses are like the non-parametric equivalent of Pearson correlation analyses. So with the Pearson correlation analysis, you assume that you have normal data and that the data are linearly related to each other. But with the Spearman test, those assumptions don't have to be met. So you don't need to have normally distributed data, and even though you assume that as one variable goes up, another variable goes up, or the other variable goes down, the relationship between those two variables doesn't have to be linear. And while you would normally use continuous data for a Pearson test, with the Spearman test you can use ordinal data. So ordinal data are basically groups that you can order, hence the name ordinal. So for example, level of income could be like low, medium, and high. So there's like three groups, but there's an inherent order to those groups. So that would be one example of ordinal data. So in this one, if we take a look at in this video, if we take a look at the Excel spreadsheet, we're going to imagine that we're interested in the relationship between education, salary, and job satisfaction. So in this spreadsheet, 1 is going to represent like a low level of education, 5 will represent a high level of education, and the same thing for salary. So 1 is low, 5 is high, and with job satisfaction, 1 equals dissatisfied and 5 equals satisfied. So if we go to SPS, we can take a look at how to enter these data into the program. So we can go to variable view to start with. And I'll just tell SPS the names of these variables. So this one we can call one of them education. We can call one of them job underscore, because we can't use a space, satisfaction. And the last one is, this is wrong around actually. I'll put this one as salary. And then put this one as job satisfaction. Okay. So once I've done that, I'm just going to use this values column to give the numbers some names. We have those numbers between 1 and 5 we saw before. So now I'm just going to give those numbers some names. So we'll say 1 equals no education, or we can just put none. 2 equals high school. 3 equals, let's say, bachelor. 4 is masters. If it's not clear, I'm just clicking add every time I enter something, so add, that appears there. So 5, we put that as PhD. Add. Okay, so we have 5 numbers and we have 5 names for those numbers. So I'm just going to do the same thing for salary and job satisfaction. So 1 is going to be, let's say, low. 2 can be quite low. 3 will be medium. 4 will be quite high. And 5 will be high. Okay, so I've entered those. I'll just go to OK, and then I'll just do the same thing for job satisfaction. So 1 can be dissatisfied. 2 can be quite dissatisfied. 3 can be neutral. 4 can be quite satisfied. And 5 can be satisfied. Add. Okay. All right. So we've now told SPSS what those numbers are. I'm just going to use this measures column to indicate what type of variables these are. So these are all ordinal variables, as I mentioned before. And I'm going to use the dates view, and we can see that these names have appeared at the top of these columns. Then it's just a matter of copying and pasting this data from the spreadsheet. So copy and paste. And we should see that, paste, 1 second, copy, paste, what's going on? copy, paste, paste, paste. Okay, there we go. So all those numbers, so for example, if we look here, we have a 1 in the education top row, but this has been replaced by the word none in SPSS. If your file doesn't look like this, if you just see numbers here, even after you've given the numbers some names, you can just go to view and check that value labels is ticked. Okay, so I mentioned that one of the assumptions of the Spearman's test is that as one variable goes up, another variable goes up, or the other variable goes down, but that relationship doesn't have to be linear. So let's just take a look at how we can look into that assumption. So we'll do this by going to graphs, down to legacy dialogues, and to scatter/dots. I'm going to choose simple scatter, and then define. I'm going to put education in the x-axis, job satisfaction in the y-axis, then I'll go to OK. And we can see that basically as education goes up, so this is education at the bottom, this is job satisfaction on the side, this is low education, this is low job satisfaction. So we can see that as education goes up, so does job satisfaction. So we kind of have a diagonal line like this. This suggests that the relationship is going to be positive. So a positive correlation just means as one variable goes up, so does the other variable. It would also be okay if we saw the opposite direction here. So if we saw that the line went in this direction instead, that would also be fine. That would just indicate that the relationship is negative rather than positive. So let's just do a couple more graphs for the other potential relationships. So graphs, legacy dialogues, scatter/dots, simple scatter, define. I'm just going to move job satisfaction out. I'm going to put salary there. And that's just going to create the same type of graph. Again, we can see that there's basically a positive correlation between them. As one goes up, so does the other. And then we'll just do the last one. So graphs, legacy dialogues, scatter/dots, simple scatter, define. And this time let's go, so we're going to put job satisfaction here. I think that's the one we haven't checked yet. Job satisfaction and salary. So far we've looked at education and job satisfaction, education and salary, and now we're looking at salary and job satisfaction. And we can see that we have the same thing again. So as job satisfaction goes up, so does salary. So that assumption that there is like a relationship between the variables, as one goes up, so does the other, or down, that assumption has been met. So once we've checked that, we can run the analysis itself. So I'll go to Analyze, then down to Correlate, then to Bivariates. And then I'm just going to transfer all of these variables across to the variables box. I'm going to check Spearman and untick Pearson. And I don't need to check anything else, so I'll just go to OK. And that produces this table for us. So if we take a look at education first, so we go across from here and we'll get to salary. And we can see the value is 0.763. Basically, correlation values range from -1 to +1. And if they're close to +1, that means it's a strong positive correlation. If they're close to -1, that means it's a strong negative correlation. And if they're somewhere close to 0, well, if they're 0, there's no correlation. If they're, let's say it's -0.1, that would indicate a weak negative correlation. So in this case, we don't have a minus symbol, so we know that this correlation is positive. And we also know that it is significant because if we look at this sig value below, it's below 0.001. So really the value, SPSS only shows this value to 3 decimal places. So the value isn't really 0, it's just somewhere below 0.001. So we can say that there's a positive, significant relationship between education and salary. And then if we look at job satisfaction, we can see that the same thing is true for that. So education, job satisfaction, we have another value that's close to +1. And again, we have a sig value that is less than 0.001. So another positive, significant correlation there. If we look at salary and job satisfaction, so salary here, we'll go across to job satisfaction, and we have this Spearman's rho value of 0.836. So this is a positive, significant relationship, and we know it's significant because, again, this value is below 0.001. So those are the results. That's how to interpret them. And let's take a look at how we can report them. So let's have a look at this paragraph first. So I've just started off by saying what test was run. So we ran Spearman's rank order correlations to examine the relationships between level of education, salary, and job satisfaction. And these results are quite easy to report because we observed the same type of correlation between all of the variables. So we can say there were positive and significant correlations between education and salary, education and job satisfaction, and salary and job satisfaction. And we've included some stats here. So let's just take a look at where those stats come from. So we've got the RS equals 0.76 here. So that's the first one we looked at before because we're looking at education and salary in this case. So education will go across to where it says salary. It says 0.763, and we've just rounded that value here to 2 decimal places. We've got n equals 20 next. That is actually just the number of participants. If we're not sure about how many participants we have, we can also just check this table because it says n equals 20, and that's where that comes from. And the last value then is the p equals less than 0.001, and that's just this sig value here. It's 0.000. If that value had been 0.001 or above, I would have used p equals and then whatever the value is. So if it was if the sig value was 0.053, I would have written p equals 0.053, and I wouldn't have used the less than symbol. And then we just have the same thing for these other relationships. So hopefully that will be obvious where those values come from. In the case of this particular analysis, I probably wouldn't present the results in a table just because there are only 3 correlations and it's very easy to report them just in text. But if you had lots more correlations, it might be easier for the reader to figure out what's going on if you included the stats in a table instead of in a paragraph. So let's just take a look at what a table might look like. So this is with an APA style. You can tell because, well, for example, this table 1 is above the actual title. The title is italicized. It has capital letters, with the exception of short prepositions such as and articles, but we don't have any articles in this title. And also the table doesn't have any like vertical lines within it. It's all just horizontal lines. So that's sort of the APA style. So these are just the RS values that we looked at before. So 7.6 is there, and I have the same thing here. So that just represents the relationship between salary and education. And I've put this little asterisk here because the value, just to indicate that the value is significant. So the asterisk tells the reader that the value is less than 0.001. If you had some values that were less than 0.001 and some that were less than 0.05, I might use 2 asterisks to distinguish between those. So I could use 2 asterisks to stand for 0.001 or below that value. And I'll probably use 1 asterisk to refer to values below 0.05. So I think that's about all there is to the Spearman's correlation analysis and how to present them. If anything's unclear, please just let me know in the comments. And thanks very much for watching.